So today we are going to look at operations with radicals, adding, subtracting, multiplying, and dividing. So basically with addition and subtraction, you have to determine, do you have like radicals? And to determine if you have like radicals, they must have the same terms under the same radical to combine. So I would highlight that if I were you. In addition to that, your radicals also have to have the same index. So, and same index. So that means they have to have the same radicand, the number underneath the radical, and the same index. So they have to both be taking the same root, square root, cube root, whatever. You can't add a square root to a cube root. Then I also want you to consider the fact that adding and subtracting radicals is very similar to variables in combined like terms. So for instance, let's identify whether, based upon what we've talked about here, is the square root of 3b and 2 times the square root of 3b like radicals or unlike radicals? Do they have the same index? Yes. Do they have the same radicand, which is the number underneath the radical, 3b? 3b, yes. So they are like radicals. So if you were to add these, the coefficient in front of square root of 3b is 1 square root of 3b. So if I were to add, I apologize, but I'm sick. So this is going to be really fun for me. So if I add one of these and 2 of these, don't I have 3 of those all together? So 1 radical 3b plus 2 radical 3b is going to equal 3 radical 3b's. So it would be very similar as if I just let radical 3b be an x. So I would have 1x and then 2 x's. 1x plus 2x is 3 x's. Okay, so I just popped a cough drop in my mouth, so hopefully things will get better. So if it sounds like I'm eating something, I am. All right, so then look at the next one. Do we have the same index? No. So it doesn't matter that they both have a 3b underneath, their indexes are not the same. So they are unlike, mostly because this is different than this understood index of 2. So not the same indexes. And then look at the last set. Same index? Yes, they're both square roots. Same radicand? No. So these also are unlike because one has a 2 and one has a 3. So not the same radicand. Okay, so now let's actually get to some addition. So in this first one, we can only add radicals that are like radicals. So I have the same index and the same radicand. So once you identify that you have like radicals, then just look at the coefficients. So the number in front of the radical is 1. The number in front of that radical is 1. So if I have 1 rad 3 and I add to it 1 more rad 3, it means that I'm going to have 2 radical 3's. Remember how I said this is no different than adding variables? So let's say that I let radical 3 be x. If I had 1x plus 1x, because they're the same thing, I would have 2 x's. So one of these plus one of these gives me 2 of those. Same thing here. One of these plus one of these gives me 2 of those. So with like radicals, the radical string doesn't change when we add and subtract them. Just like with variables, the variable string doesn't change when we add them. So let's look at number 2. I have the same index and the same radicand. So they're like radicals. So I want to look at their coefficients. So I have a 4 in front of the first one. There's nothing in front of the second one, so I'm going to assume it's a 1. So I just look at the 4 and the 1. So 4 plus 1 is 5. So this equals 5 radical 2. Then the next one has 3 terms. This one doesn't have a radical at all, but these two both have a radical 3, and they have an index of 2. So these are like radicals. This is not. So I'm going to underline my like radicals, and I'm going to double underline the one that's not. So the 7 remains as 7, but I'm going to look at the coefficients. 8 plus 2 is 10 rad 3s. Now I cannot add the 7 and the 10 and make it 17 rad 3 because the 7 does not have a radical 3 attached to it. So this is not like this. So I cannot combine them any further. That's your answer. So now when we get to 4 and 5, let's make these a little bigger. So for 4, none of these radicals are alike. They're all square roots, which is good, but none of the numbers under the radicals are alike. And furthermore, I can actually simplify 12, 32, and 48. And so we need to simplify the radicals first. So that's one of our things that we need to look at. So let's go ahead. If I prime factor 12, now we spent a lot of time prime factoring in the previous lesson, and so I'm going to assume that you can prime factor 12, you know, with the prime factor trees. So I'm going to let you do that on your own. I'm not going to waste the space here. But if I were to prime factor 12, it would come out as 2 times 2 times 3. And then plus, if I were to prime factor 32, there are 5 2's in 32. Plus, if I were to prime factor 48, which is 6 times 8, there are 3 2's in 8, and a 2 and a 3 in 6. So now I'm just taking groups of 2 because they're square roots. So I get a 2 out in front, and then I have a 3 left over underneath the radical, so I have square root of 3. I can take out 2 2's, so I have plus 2 times 2 out in front, and a 2 left over underneath the radical, so square root of 2. I can take a pair of 2's here and a pair of 2's here, so plus 2 times 2. And then I have this 3 left under the radical, square root of 3. So then if I do my multiplication, I've got 2 rad 3, that didn't change, but 2 times 2 is 4 radical 2. 2 times 2 is 4 radical 3. So now, not all of these have the same radicand underneath the radical. So out of these 3, only these 2 are like radicals. So I'm going to underline those. This is like to this one, and then this one is all by itself. So equals, once I identify my like radicals, just add the coefficients. So 2 plus 4 is 6. So I get 6 radical 3's. And then this one's on its own. So then I have plus 4 radical 2. Since those are not like radicals, you cannot combine those any further. Now the last one looks different from all the other 4 because we have parentheses grouping these 2 together and parentheses grouping these 2 together. In this case, the parentheses really don't mean anything. They're just saying take this group and add this group. Oftentimes students get confused when they look at a problem like this because they think we're going to take this and multiply it to this. But we have addition in between, so don't get fooled. What you want to do is look at the number that's in front of the parentheses and distribute it in. Since there's nothing in front of my parentheses, I can only assume that there's a positive 1 here and a positive 1 there. So then if I were to distribute a positive 1 into the parentheses, nothing would happen. So I'm going to drop all the parentheses. I have a 3 minus the square root of 24 plus 8 minus the square root of 96. So at this point, I want you to stop the video, and I want you to simplify this, and then I want you to add the like radicals and other like terms together and see what you have. Stop the video. Okay, so at this point, I'm assuming you've completed your problem, right? So 24 is 8 times 3, so I've got 3 2s and a 3. That's your 8 times 3 plus 8 minus, and then 96 is 3 times 32. So I have 5 2s and a 3. Then I'm taking square roots, so I'm groups of 2. So a group of 2, that's going to come out in front, and I'm going to have 6 underneath because you got to multiply that together. So I have 3 minus 2 square root of 6 plus the 8. Then I'm going to take groups of 2 for the next one, so 2 times 2 with 6 left over. So I get plus 4, because that's 2 times 2, square root of 6. So now I want to look for like radicals. So both of my radicals have the same radicand, so those are alike. And a negative 2 and a positive 4 gives me a positive 2 radical 6. And then my numbers, all numbers are alike. So any integers are alike. So 3 plus 8 is 11. And I cannot add the 11 and the 2 together. Right here, I can't make that 13 rad 6 because this does not have a radical 6 attached to it. So now let's look at subtraction. How is it different than addition? Well, there's only one thing that makes it different. And once you take care of that one thing, it's exactly like addition. So you see these parentheses again. So again, I want you to focus on what's in front of the parentheses. So for the first parentheses in number 1, it's got a coefficient of 1. But the second parentheses has a coefficient of negative 1. So when we distribute the 1 into the first set of parentheses, nothing much happens. We get 3 minus the square root of 7. That's a really sad 7. But the second one, when I distribute this negative 1 in, it changes all the signs. So I actually get a minus 8 instead of a positive 8, and a minus 4 radical 7 instead of a positive. Now it's just like addition. Look for your like terms. I have a minus rad 7 and a minus 4 rad 7. Remember, there's really a negative 1 in front of that minus rad 7. So I'm going to add their coefficients. And a negative 1 and a negative 4 is really a negative 5. So I get a negative 5 radical 7. And then the numbers 3 and negative 8. What's 3 minus 8? That's going to give us a negative 5. So this is my solution right there. So with number 2, number 2 has just one set of parentheses. So we're taking this plus this, and we're subtracting all of this. So because we're subtracting all of this, we have to distribute that negative all the way through. Remember, it's really a negative 1 in front, and we're going to distribute that. So we end up with 4 plus the square root of 27. Negative 1 times a negative 15 is a positive 15. And a negative 1 times radical 48 is negative square root of 48. Now at this point, it's just like what we did with addition. You're going to simplify your radicals, because right now these aren't alike. And we still have to simplify them. Even if they were, we still would have to simplify them. So I'm going to prime factor what's underneath. And I end up with 4 being 4, so that doesn't change. But 27 is 9 times 3, which gives us 3 3s. Plus 15 minus 48 is 6 times 8. So you get 3 2s from the 8, and then a 2 and a 3 from the 6. Because I'm dealing with square roots, I'm going to take groups of 2. So I'm going to bring a 3 out in front. So I have a 4 plus 3 square root of, and I have this 3 here left over. So I'm going to put the 3 underneath there. Then plus 15 So then groups of 2, I've got 2 groups of 2, so I'm going to multiply a 2 times 2 out in front, and then times that -1. So -1 times 2 times 2 is -4, and of course we have this 3 left underneath the square root. So now when I try to combine terms, I have like radicals here. They both have a square root of 3. So I'm going to underline those. And a positive 3 and a -4 is -1 square root of 3. You can write -1 or just a negative. Then the 4 plus the 15, 4 plus 15 is 19. And that's it. Now this last one I want you to do on your own. So make sure you distribute the negative, simplify your radicals, and then collect like terms. Like radicals, like terms. All right, so pause the video. Okay, so if I drop my parentheses, the first one doesn't change. But the second one, when I distribute this negative all the way through, we get a -8, but a positive square root of 96. Now we already factored these before, so 3 minus 24 is 2 times 2 times 2 times 3 minus the 8, plus the square root of 96 is 2 times 2 times 2 times 2 times 2 times 3. Okay, so then I want groups of 2. And then here I'm going to have 2 come out. I'm going to have 6 left over here and 6 left over there. So I end up with 3 minus 2 square root of 6 minus 8 plus 2 times 2 is 4 square root of 6. My square roots of 6 are alike. So a -2 and a positive 4 is positive 2 square root of 6. And then my 3 and my -8 gives me a -5. And that's as far as they can go. Well, let's multiply. How fun. So with multiplication, and let me go back to here, you can only multiply coefficients to coefficients and like radicals, well, not like radicals, but you can only multiply, when we say coefficient to coefficient, like base to like base with variable multiplication, same thing kind of applies here with radicals. You're going to multiply what's outside to what's outside on a radical and what's inside to what's inside. So you don't have to have like radicals to multiply, but you do have to have like indexes. So let's start here. So we'll start out simple, a monomial times a binomial. So we're going to distribute anything that you see out in front. So again, I'm going to multiply what's outside to what's outside and what's inside to what's inside. Now this is going to be no different, I'm going to do here off to the side, than if I did 4 times 8 plus, instead of the square root of 2, I'm going to make it an x. So if I were to multiply this, I would have 4 times 8 is 32. And 4 times the x would be positive 4x. You would just tack the x on. 32 and 4x could not be combined because they're not like terms. One has an x, one doesn't. So the same thing's going to apply, but with the radical. So the 4 times the 8 is 32 plus, and then you've got 4 times what's in front. So you have to multiply what's outside to what's outside. So right here is what's in front. And so we need to understand that there's a 1. So 4 times 1 is 4. And then we just tack that radical on just like we tacked the variable on before. The first term here doesn't have a radical to multiply to this, so we just tack it on. Now these are not like terms, and that's as far as you can go. That's your answer. It's as simple as that. So then you do number 2 on your own. The only difference is that number 2 starts with a radical. So you can only multiply this 3 with something that's underneath a radical. Otherwise, the radical 3 has a 1 in front, and the minus radical 6 has a -1 in front. So you're going to distribute this into the parentheses. So pause the video, try it. Okay, so if I multiply what's outside of what's outside, I get 1 times 7 is 7. And then we want to multiply this radical. Well, this one doesn't have a radical, so remember we just tacked that on here. So you're going to get 7 radical 3. Then for the next one, you've got 1 times a negative 1, which is a negative 1. So if you want to write a negative 1, you can. I'm just going to write a negative. And then, remember, these don't have to be like radicals. 3 times 6. 3 times 6 is going to be underneath that radical. I'm not actually going to multiply 3 times 6 together because I know that I'm going to have to tear it apart in order to simplify that radical. And I know that this 6 has a 3 that I can pair up with this 3 and bring out in front. So let's go ahead and do that. So I'm going to simplify my radicals. And then 6 is 3 times 2. So then that means that I can pull a 3 out in front and leave a 2 underneath. And so my final answer is 7 radical 3 minus 3 radical 2. And these cannot be combined any further because they both have, because now we're changing that rule, because now we're adding like radicals, and these are not like radicals. So that's as far as we can go. So we're using 2 different rules here. Once we multiply, then we have to simplify the radical and then see if we can add or subtract any like radicals. So let's move over here to 3. This time we have a binomial times a binomial. And so remember, with a binomial times a binomial, you want to FOIL or double distribute. So I'm going to take this 3 and distribute it to everything here using multiplication. Then I'll take the negative 2 and distribute it to everything here using multiplication. So here we go. I'm going to multiply here. So what's outside of what's outside, I'm going to multiply the 3 to the 3, which gives me 9. And then I'm going to multiply what's inside of what's inside. Well, this doesn't have a radical, and this does, so we just tack that onto here. So I get rad 2. Then the next multiplication is all the way over here. Well, this is just 3 times 2. It's normal multiplication, which is 3. Then I'm going to multiply the negative radical 2 all the way through. So I'm going to multiply it here. So negative, remember there's a 1 in front of here. In fact, let me put that in there. So there's a negative 1 here. So what's outside of what's outside? So negative 1 times 3 is negative 3. And then rad 2 times rad 2, we're going to multiply that underneath the radical, so 2 times 2. We'll deal with that in a minute. Then I want to multiply the negative rad 2 to positive 1. So what's outside of what's outside? Negative 1 to 1 is a negative 1. I'm just going to write a negative. And then I need to tack on that radical 2. So the only radical that we can simplify is this one right here. Notice that it happens to be a perfect square because I'm taking groups of 2, and when I pull this out to multiply to that negative 3, there's nothing left under the radical. And so what you'll notice is anytime I take a radical and multiply it by itself when it's a square root, you get the number under the radical, in this case 2. So we're going to have 9 radical 2, that doesn't change, plus 3. Sorry. 2 times 3 is 6, so negative 6, and then there's no radical, and then minus the square root of 2. Then we have like radicals, 9 rad 2 and minus 1 rad 2. So 9 minus 1 is positive 8 radical 2. And then for my integers, I have 3 and a negative 6, which combine to give you a negative 3. So then what I would like you to do is to do number 4 on your own. So pause the video and do this one on your own. Okay, so I'm going to distribute the 3 to everything in the other parentheses. So 3 times 8 is 24. 3 times radical 7 is positive 3 radical 7. We're multiplying what's outside to what's outside. That's where the 3 comes from. And then this one doesn't have a radical. That one does, so we tack it on. Then a negative radical 7 is going to be multiplied here. Remember, there's a 1 here and a 1 here. So negative 1 times 8 is negative 8. Then tack on that radical 7. Then negative 1 times positive 1 is negative 1. And then underneath the radical, you're going to multiply the 2 7s. But remember, this is a radical times itself, so this becomes a perfect square that's going to get pulled out as a minus 7. So we have 24 plus 3 radical 7 minus 8 radical 7 minus just 7. So now these are our like radicals, and a positive 3 and a negative 8 is minus 5 radical 7. And then a 24 and a minus 7 is 17. And that's as far as you can go. Division. So the big thing about division is that radicals are not allowed in the denominator, or fractions. So we can't have a fraction underneath a radical, because that counts as a radical in the denominator, and we can't have radicals in the denominator. So we're going to have to do what's called rationalizing the denominator, and that's how we end up dividing. So over here, and we kind of did this before, we've talked about it a little bit, but I've got a square root of 4, and this is actually a perfect square because it's square root of 4 is 2. So if we simplify this, we actually don't end up with a radical in the denominator. So square root of 4 is 2. And so then the 5 is up top. And since there's no radicals in the denominator, we're done. But on number 2, remember, you can split up this fraction into 2 separate radicals, square root of 7 over the square root of 3. And the square root of 3 is not a perfect square. So what would I have to multiply this by to make it a perfect square? I have an index of 2, and I have 1 3. For this to be a perfect square, I would have to have 2 3s to make a pair. So if I want to do what's called rationalizing the denominator, I'm going to multiply it by the same index radical, in this case the square root. Because I need 2 3s and I already have 1, I only need 1 3. In order to have like fractions, I have to multiply the top of the fraction exactly the same as I multiply the bottom of the fraction. So that numerator and denominator have to be multiplied by the same thing in order to keep an equivalent fraction. So if I multiply the bottom by radical 3, I have to multiply the top by radical 3. So everything's underneath the radicals, so rad 7 times rad 3, just going to multiply it together. You get the square root of 21. I know I can't make any perfect pairs because 7 and 3 are both prime, so I just multiply those together. But remember that a radical times itself is the number under the radical. So at this point, we need to start to shortcut. Instead of writing the square root of 9 or the square root of 3 times 3, you should just start to realize that a radical square root times itself is going to give you the number underneath the radical. Now, a lot of you are going to try to divide the 3 into the 21, but remember, this is outside the radical, that's inside the radical. They cannot communicate. They can't touch each other, nothing. So I cannot divide the 3 into there and make it a square root of 7. So you can only simplify, if I can talk today, what's outside of a radical to what's outside and what's inside to what's inside. So let's look at another one. So both of these 3 and 4, I want you to stop the video. I want you to try those on your own and see how you do. Okay, so for number 3, we have a square root, so we need a pair. We already have 1 5. I need a second 5 to make it a perfect square. What I do to the bottom, I need to do to the top. But this time, this is outside and this is inside, so I cannot multiply them together. So we end up with 3 rad 5 up top. Rad 5 times rad 5 is 5. So then you want to look at what's outside the radical to see if it can reduce. I cannot reduce 3/5, so this is my final answer. Now remember, on number 4, we split this up as radical 2 divided by radical 7. So in the bottom, I need a perfect square. So I have 1 7. To make 2 7s, I need 1 more. So I need a square root of 7 to make 2 total 7s. What I do to the bottom, I do to the top. So these are both underneath the radical, so I can multiply them together. And there is no way to break up 2 or 7, so I'm just going to multiply them. So 2 times 7 is 14 over rad 7 times rad 7 is 7. Now again, this is outside the radical, that's inside the radical. I cannot cancel the 7 with the 14. You have to leave it alone. Last page. So here's some more division problems that are a little bit more tricky. So I want you to try these on your own and then pause the video and look at the answers. Okay, so as it happens, the square root of 9 is a perfect square. So the square root of 9 is 3, and the square root of 4 is 2. So no rationalizing needed on that one. Then on the second one, the square root of 8 can be broken into 2 times 2 times 2 over the square root of 9 can be broken into 3 times 3. So I already have a perfect square down here. No need to rationalize it because I'm going to pull out a 3 out in front and there's nothing left under the radical. So it's gone. But upstairs, I'm going to circle 2, so a 2 comes out in front, but you have that 2 left underneath the radical. Then you need to look at what's outside the radical and make sure that it cannot be simplified. I cannot divide 2 and 3 by the same number, so that is your final answer. Then on this last one, the square root of 20 can be prime factored as 2 times 5 over, then I have 2 on the outside, and I have 4 is 2 times 2. Now technically, because these are underneath the radical, I could cancel this 2 with this 2 and that 2 with that 2, and I wouldn't have to rationalize it. That's actually the easiest way. If there is one number in the numerator underneath the radical that you can cancel with the same number underneath, why not? So now there's nothing left under the radical, and you end up with square root of 5 up top, but on the bottom just a 2. And that's it. That was, oh, nope, I have another one. All right, so this last one, so same thing as kind of what I was just talking about. Since both of these are outside the radical, I can cancel this 5 with that 5. And then what's underneath the radicals, remember 6 prime factors as 2 times 3. And we have that over the square root of 3. Since we have a 3 underneath both of these radicals, I can just cancel this 3 with that 3. And we have left a square root of 2 up top. And if everything's gone from the denominator, we have a 1. And we don't write anything over 1. So then our final answer is the square root of 2. Now let's talk about what's called a conjugate pair. Make this a little smaller. So what happens if we have addition or subtraction in the denominator? Multiplying by the square root of 2 here is not going to get rid of the radical. So a conjugate pair means that we're going to multiply by the same thing that you see here, except we're going to change this middle sign. Essentially, we're creating the difference of two squares factor pattern. So for instance, if this is my binomial in the denominator, the conjugate pair would look just like it, a 2 and a radical 2, but instead of a minus, I'm going to put a plus in the middle. And you're going to see some magic happen. What I do to the bottom, I have to do to the top. And then from here, we're just using our multiplication skill. So if you can see that anytime you have addition or subtraction, underneath here, notice that none of these had addition or subtraction. You've got to multiply by what's called a conjugate pair. So let me make this bigger. Okay, so I am going to distribute the 2 up top. So I'm going to multiply this 2 into here. So remember, we multiply what's outside, what's inside to what's inside. So 2 times 2 is a positive 4. And then this 2 is getting multiplied by a 1 that's in front of here. So 2 times 1 is 2. And then we tack on that square root of 2 over. In the denominator, we are going to multiply this 2 times this 2, and we get a 4. And this 2 times this radical 2, remember what's outside is 2 times 1, which is 2, so plus 2, and then tack on that radical. Then I'm going to distribute this negative 2 all the way through. So what's outside here is negative 1 times positive 2 is negative 2. And then we're going to tack on that radical 2. Then we have a negative 1 times a positive 1, so that gives us a negative. And then we have two 2's because we've got radical 2 times radical 2. So remember, anytime I take a radical times itself, we get the number under the radical. Because this is 2 times 2 is 4, the square root of 4 is 2. So we get a minus 2. Now because these are like radicals, they both have a rad 2, the coefficient is positive 2 and negative 2, they actually cancel each other out. A plus 2 and a minus 2 are going to cancel each other out. And then you're left with 4 plus 2 rad 2 over the 4 and the minus 2, which equals 4 plus 2 rad 2 all over 2. Then what I want you to get in the habit of doing is splitting this up and see if I split this and divided 4 by 2 and this by 2, would both of these divisible by 2? Yes. I can divide 4 by 2 and 2 by 2. So let's go ahead and do that. So I'm going to move this over a little bit. So I'm going to break it up, and I'm going to take the 4 and divide it by the denominator of 2 and add the 2 rad 2 and divide it by the denominator of 2. So 4 divided by 2 is 2, and remember these are going to cancel, and you're going to get plus radical 2. So there is no longer a radical in the denominator. So look at that again, and then I want you to try this one on your own. It's a little busy. It's a little difficult, but try it on your own and then restart the video. Okay, so the conjugate pair to this one would be the same thing as what you're looking at. You're still going to have a 4 and a 3 rad 2. But instead of this plus that's here, you're going to have a minus here. Conjugate pairs always look the same, but the signs are different. So I'm going to multiply the top by 4, minus 3 rad 2 equals. Okay, so I've got this times this. Well, I have this is inside the radical and that's outside. So outside here's a 1 times a 4 gives me a 4, and then tack on that radical 2. And then I'm going to multiply this. So what's in front is a 1 times a negative 3 is a negative 3. Then underneath the radical, oh, actually we don't have underneath the radical because what do we have? Take this away. Underneath the radical we have 2, rad 2 times rad 2. Well, rad 2 times rad 2 is 2. So I'm going to multiply this by 2 over. Then we are going to distribute 4 times 4. Well, that one's easy. It's 16. And then 4 times negative 3 rad 2. So outside is 4 and negative 3. That gives me negative 12. And then tack on that radical. Then we are going to distribute the 3 rad 2 inside. So what's outside is 3 times the 4, which is 12. And then tack on the radical. And then 3 times negative 3 is negative 9. And then rad 2 times rad 2 is just 2. It's a radical times itself. So times 2. So I'm going to move this over. All right, so let's start cleaning things up. So up top, I have 4 radical 2, and then negative 3 times 2 is negative 6 over. In the bottom, I have 16. These are opposite signs, so they cancel each other out, and then a negative 9 times 2 is a negative 18. So that leaves me with 4 radical 2 minus 6 over 16 minus 18 is a negative 2. So then, can I divide 4, because that's what's outside, to what's outside? Can I divide 4 by negative 2? Yes. Can I divide negative 6 by negative 2? Yes. So that is what we're going to do. I'm going to split it up. So 4 radical 2 over negative 2. I'm going to make it a plus because I'm going to leave the signs with the numbers. So negative 6 over negative 2. So here, 4 divided by negative 2 is negative 2, and then tack on that radical 2. And then negative 6 divided by negative 2 is a positive 3. And you're done. So, good luck on your homework. Make sure that you're asking me lots of questions. Feel free to bug me. All right, have a good day.